There are a few established best practices when it comes to designing and writing controllers. Mainly, these best practices are also best practices among any kind of object or class. The first is to only have your controller do what it is responsible for, which is coordinating between the model and the view, or in other words, don't have the controller do things it's not supposed to do. Let's look at an example. Here I've got an overly simple controller. This controller handles some interaction on a class registration page. The controller is doing two things. It's initializing some kind of model object that contains a list of classes in the current student schedule, and it's defining a register function that is probably called when the user clicks on something to add a class to their schedule. So the problem here is that registering isn't a piece of view interaction. The controller isn't mediating between the model and the view. If you look closely here in the register method, the controller is deciding exactly how the model handles the new class registration. This is business logic. The logic about how the model adds classes to a schedule belongs in an object that handles business logic, or in other words, a service. Let's try doing a bit of rework here and see if we can move some inappropriate responsibilities out of the controller. So the first thing I'm going to do is I'm going to add a new collaborator called a schedule. And I'm going to come down to my scope and just assign the scope's schedule property to be that schedule class. Now I'm going to come down to my register function and I'm going to change this so that it calls that new schedule service. So I'm taking in the model and I'm binding it to the scope. Remember, this is our first responsibility, setting up the scope for binding. Now the view can bind to the data in the schedule. Then the register function merely calls register on the model and passes in the correct entity. In fact, we could likely just go into our view and set up the binding on the click event to call the schedule's register method directly. If there's nothing we need to do before dispatching that call off to our schedule service, then there's no reason for the controller to sit in the middle. The next guideline is going to be a common best practice among all the Angular objects. That is, to make sure that your controller doesn't have too many collaborators. Now in this case, the question of exactly what is too many is not simple and has no objective answer. But basically, as soon as your controller gets more than 3 or 4 collaborators, it's time to look at how many things your controller is doing. Let's look at an example. I've got a controller here that has 7 collaborators, the scope, and 6 other services. This controller would be the controller that handles registration of a user. The problem is that if it needs those 6 services, then what exactly is it doing? Is this controller showing the list of classes and instructors, the student schedule, and marshalling off registration logic, plus displaying information about the current user, and about all the students, plus checking policies before registration? Obviously, this is too much for any one class to do. It's time to consider how the code interacts. Now you may be saying to yourself, but what if I need the controller to do all those things? Well, there are a couple strategies to use to limit the number of collaborators that a controller has. The first of these is to simply make the controller do less things. The best way to do that is to cut up the page into smaller chunks and make some of the child controllers handle the pieces of the page. We will look at doing this in more depth later on in the course, but for now let's just recognize that there is no reason to limit an entire page to just one controller. Dividing up the page into smaller pieces is a great way to get a controller to do a more focused job. In our example code here, if another controller was handling some of the areas of the page that displayed the info about the current user and their schedule, and the instructors and students, then that right there would likely eliminate 4 of those dependencies listed. So always keep an eye on how many collaborators your controllers have and try to keep them to a minimum. The second way to limit the number of collaborators is to create a Facade class to aggregate the interaction with several collaborators into a single collaborator. Let's imagine for a moment that the schedule service, the instructor service, and the current user's service were all used when binding data to the part of the page that displays the current user's schedule. Well, we could easily create a new service called current user schedule. The service might look something like this. This service hides the details of working with 3 separate services and abstracts those interactions into one simpler interface that works better for our controller. Using techniques like these can limit the number of collaborators and keep the code in your controllers much simpler than it otherwise would be if you just simply let your controllers grow without restraint. Another source of collaborators you might see in controllers is globals. A great example of this might be third-party libraries like underscore, or maybe some global classes or variables that you create in other parts of your application. Let's see how that might look in a controller. Here I have a globals file that creates a global variable with an object in it. And then, later on in my controller, I need that global variable. So I just use it since it's already global. Well, this is a really insidious dependency. One of the great parts about Angular is the fact that any of your services or controllers lists its dependencies up here in the function declaration. That way you get to see how many dependencies a given controller or service has. But with globals, you have no way of knowing how many global dependencies your controller is using. Thankfully, there is an easy way to add global variables to Angular so that they can be treated as dependencies in your controllers and services. I'm just going to go into my app.js file, and right here I'm going to say angular.module, grab the app module, and I'm going to call .value. Now if you're not familiar with what .value is, we'll cover this later on in the course. I'm going to create a new service called gdata, and then I'm going to pass in that global data global variable. Now I can go back to my controller and I can add that gdata's dependency. So that gives me a really easy way to turn global variables into Angular services. There's one other source of dependencies we need to mention. These are dependencies that are already on the scope. Now later on in the course we will discuss the scenario where a parent controller and a child controller share items on the scope, so we won't go into detail about that here, but let's just talk about the effect on a controller when there is already an object on the scope that your controller uses. Here I've got a controller that's got a register method that it's adding to the scope. But if you look down in here, you can see that it's relying on the fact that there already exists a current user variable on the scope. Yet that's not created here by this controller. Ultimately, this kind of dependency is just like a global dependency in that it creates an invisible coupling between your controller and some other code somewhere else in your application. The benefit of doing this is that for something that you use all the time, like information about the current user, the data is already there and you don't have to bring it in specifically and bind it to the scope. But the drawback is that you might not know that there is a collaboration going on, so your controller has more collaborators than you know about, and therefore is probably doing more than you realize. The third and final guideline we will talk about when creating controllers is that they should be testable. The question here is, what exactly does testable mean? Well, conveniently enough, a testable controller pretty much follows the other guidelines we've discussed so far. Let's look at some code to get a more concrete idea of this. I have here a controller that has a lot of collaborators. You can see in the register function that the collaborators are heavily used to ultimately register the user. Now, this code may be contrived, but it is far from unrealistic. If you have any experience with unit testing, you may be looking at this code cringing about how much work you would have to do to mock out each of these dependencies in order to test the register function. So although it may be technically possible to test this code, it would hardly be called testable. The same principle applies to all the other recommendations we have covered. If your controller is manipulating the DOM, then it will be tough to test. If you're too tightly coupled with another class, then it will be tough to test. If you have a lot of business logic in the controller, or if your controller is simply doing too much work, then it will be tough to test. So this is the kind of thing to look for when you are writing a controller. If it becomes painful to test your controller, then you are probably missing out on a way to simplify your code and thereby simplify your tests.